Okay, so we've got a good picture here. When I graph it, got a parabola. It's like that. Now, wait, let me make sure. Does it go through? Yep, it goes through 0, 0. So let me draw that a little better. And pretend that's curvy. Okay, so we want the graphs of that and the line y equals 2. Well, where do I draw the line y equals 2? Do you see how 2 is right in the vertex? Yes, no? Everyone see that? Yeah. I think I'm missing something. Line y equals 2. They'll go right through the vertex. Yeah, I do think I'm missing. Am I? Let me look. Find the region between the graph and line y equals 2. What about the y-axis? Yeah, I'm pretty sure I'm supposed to have between the graphs of that, comma, x equals 0. Pretty sure I'm supposed to have the y-axis as well. So now you might be asking, well, which chunk is it? This chunk? Because that's in between the curve and the line, right? Or this chunk? They're the same, right? So you can pick one. It doesn't matter. Correct? Which one you want to pick?
The top one.
Top one. So this is my area. When I revolve it about the y, it'll look like that.
Like an acorn hat.
Like an acorn hat, yeah.
Okay. Yeah. I think that's a pretty accurate description.
Okay, so let's set up my area function, my a of x. Now, once again, what shape is it? Circle. It's always going to be circle because I revolved it perfectly. I didn't change the distance as I revolved it around, so it's going to be a nice, neat circle. So now I just need to work on finding my radius. Well, the radius goes from here to here. So from the axis to the function is just the function. Yeah? And it better be in terms of y. If I revolve about the y-axis, my whole interval better be in terms of y. That doesn't change. Just like when we did area, if you had a side to side, it had to be all in terms of y. Yes? Same thing here. If I revolve about the y-axis, it's got to be in terms of y. So my area function is pi negative y squared plus 4y squared. So now when I go to do my interval, I'm going to put the pi out in front to not even mess with it. Yeah? Now I need to find my bounds. Now I should be looking at the y. Okay? 2 to 4. Now you shouldn't need a calculator to know that because when this equals 0, correct? When you just factor out a y, you're going to get 4. Everyone see that? Okay. So let's do that. Let's multiply that out. So I'm going to have y squared negative y squared plus 4y times negative y squared plus 4y. So I'm going to get y to the 4th, let's see, negative 4y cubed, negative 4y cubed, negative 8y cubed, plus 16y squared. So I have pi from 2 to 4, y to the 4th minus 8y cubed, plus 16y squared. Am I correct so far? Better check me. We don't want to make a mistake. Okay. So what's my antiderivative?
Y to the 5th minus 2y to the 4th.
Mm-hmm.
Plus 16/3 y cubed.
Y cubed. 2 to 4. We'll use our calculator so this gets a little big. But we're still going to show steps, of course. But I assume given enough time we could easily calculate this, right? Okay, what do I get when I plug in 4 for the first term?
Got 204.8.
Give me a fraction. 1,024.5. I got a couple yeses on that? Yes, no?
Yeah.
Okay. minus,
512.
anyone else get 512?
Yeah.
Yeah, I need a few more yeses.
Yeah.
Yes? Yeah, because we're typing in 4 to the 4 times 2, right?
Yeah.
Plus
1,200. Yeah.
1,204, is that what you're saying?
24.
1,024 over 3.
Three.
Okay. Minus, put some brackets in here. Plug in 2 32/5 minus 32 plus, what do we get there? 104 over 3, is that correct?
I got 128 over 3.
128. Okay, go ahead and just give me final answer there. Well, no, we'll clean up each parenthesis. That makes it a little easier. So I have pi. What do I get in that first set of parentheses when we type all those in? I want everyone doing it. Make sure we're good.
512 divided by 3.
Okay, so I want everyone doing it. Make sure we all get that.
I got 512 over 50.
Yeah,
We're
512.
Or 15 as well.
Oh, what did I do there? Okay, minus, what do we get in this second set?
I got 256 over 15. That's what I got.
256 over 15. Got a few other, wait for a couple other confirmations. Okay. So then finally when we subtract,
Yeah, 256 over 15. Yeah, that's right.
256 pi, we'll stick it back in. There we go. By the way, just because your answer isn't nice and neat, once again, does not mean it's wrong. A lot of these will work out kind of messy. And some you may have to resort to a calculator and decimals, right? They may not all be perfect, especially if your interval, this one was from 2 to 4. But remember we've encountered problems at like 2 to 3.158. They may not be nice and neat. Who was it that was just, Aaron Hunley posted something on Facebook. And in his differential equation class, he had to have done something wrong because one of his integration constants was like 16 over 695. I'm like, you never know. And then Greg Coe, the graduate a few years ago, said, no, I got the same thing. I'm like, see? They're not all going to be pretty.
He borrowed my calculator for that test too.
They're not all going to be pretty.
Yeah, he needed quad form on it.
Okay, we ready?
Okay.
Let's do a U-try.